So yesterday we looked at the distance and midpoint. The other really common formula we look at, of course, is talking about the slope of lines and what have you. Different ways we can do it. I suppose the first way, I don't know how far we're going back for that, year 7, year 8, something like that, where we just said, oh, what's the rise over the run? We just worked it out that way. So, all right, there's a line L. Of course, if we have 2 points, rise over run, well, it's easier to just use a formula. So difference in the y values over the difference in the x values. But in this case, it is important to be consistent because it will give us a different value if we swap the 1 and the 5 round, but not the 5 and the 2 round. So we'll get 5 minus 1 over 5 minus 2 for this one. So our slope is 4/3. There's another line, the most often forgotten way of finding the slope of a line, and it's rare, I'll concede that, but it's when we know the actual angle that the line makes. So let's say that's 120 degrees. Well, the slope ends up being the tan of theta. Because if you think about it, rise over run, if we were to create a right angle triangle, we'd have opposite over adjacent, hence why we can use the tan ratio. So it always goes to the positive side of the x-axis. Must be that side, and the reason for that is we know this particular blue line that I've drawn in there has got a negative slope, so we must find the tan of the obtuse angle to get a negative number. So that way we always go to the positive side. So for our example there, tan of 120, we'd end up with a slope of minus √3. And in fact now we could work out the size of the angle that the red one makes, because we know the slope of that one. Slope's 4/3, so it's just solving a trig equation really. And so approximately 53 degrees that one would make. So some important facts. We know that 2 lines are parallel if they have the same slope. And by the way, I did not spell the word if wrong. If that's you're looking at that and going, oh, look at that, you spelled if wrong. No, I have not spelled it wrong. That is the correct way of spelling if in this context. Because it means if and only if. So what that means for this one, 2 lines are parallel if and only if their slopes are equal. And what it basically means is the theorem you can work backwards or forwards. So it's true to say that 2 lines are parallel if they have the same slope, but it works in reverse. You can say, well, if they have the same slope, then they're parallel. And that's what if and only if means. You can read it backwards and forwards. Perpendicular, well, we say negative inverse, but with the calculations, the 2 slopes multiply together to give -1. Right, so A, B, C and D, there are 4 points. I just don't have the x value for the 4th one. Find out what it is if they're parallel. So if they're parallel, we know they've got the same slope. So slope AB is 2. So therefore slope CD also has to equal 2. So we solve that and we end up with A is 4. Now remember, when you're solving it, explain what you're doing. You wouldn't just go, oh, well 2 equals that, because the question is, well, why? Why are you making 2 equal that? The reason I'm making it equal is because I know that they're going to be parallel. These slopes will be equal. So that's my logic behind why I'm doing this calculation. Perpendicular, well then I'd say, well, hang on, I know that if they're perpendicular, then the 2 slopes will multiply together to give -1. So I then can solve this one. 2 times 2 on A minus 3 would be -1, and that works out to be A's -1. I suppose that really is the big difference between just a basic coordinate geometry question and where we're at now with the senior maths. It's more explaining what you're doing. What's the logic behind what you're doing? All right, we've got 3 points. They're the vertices of a parallelogram. Find the coordinates of D, the 4th vertex. So let's plot them. There's our point. Now the naming of the parallelogram is important for working out the location. So we go in cyclic order. They've said A, B, C, D. So D must be down here. So I'll just draw in the lines that we have already. There's D. Oops. At the moment I don't know its coordinates. I mean, there's different ways you could do it. The long way of doing it would be to work out the equation of CD, work out the equation of AD, solve them simultaneously. That's the long way of doing it. If we take advantage of what we know about a parallelogram, that the opposite sides are parallel, therefore the slope of AB must be the same as the slope of CD. So rise over run must be the same. So to go from B to A, I went across 3, down 5. Therefore, to go from C to D, I must go across 3 and down 5. So the coordinates would end up being 0, -10. Now, that's a heck of a lot quicker than working out the equations of the lines and solving them simultaneously. So if you want to show 3 points are collinear. So collinear, of course, means on the same line. Co meaning together, linear, line. So together on the same line. What I think this is the easiest way of doing it, is find the slope. It doesn't matter which two you pick any 2 points. So I've said AB, I'll find the slope of AB. Then do a different pair. So I did AC. Now, if they're equal, I know those 2 lines are parallel. However, they've got a common point. So therefore, it's got to be the same line. So that's enough to show they're collinear. If those 2 slopes are equal, then they've got to be the same line. They've got to be collinear. Okay. There's enough theory for us today. So 7b we'll add to our list of questions.